I'm so glad to be back here. I see already some comments, and I'm so excited for this season launch. Hello, Green Yashix. Hey, Alberto. Hello, circuit student. Hey, and a message from Shimari. That's amazing. Then we have Prata. Hello. So, I always like to start these streams just verifying that my mic is good and my camera, you can see me, you can hear me, everything. We have Anola Samundaki. Hey, buddy. Hi. Hi. So I really love, I have to say, to have you here, and I'm writing in the comments because I see there are many of you now in this stream. That's exciting. I think most of you be very excited about this Matlab stream, and I like to apologize. I have some issues with my computer, so I couldn't start this stream sooner. But let's get our our hands on Matlab because we have a lot of things to cover. So that's all the introduction. Just I have to say I'm really happy to be here and see many of the new names that I haven't read before and many others of the ones I am very used to. It's a pleasure to have you here. So let's start. Let me prepare my screen to be sure. Give me a second to do though. And let's start sharing just MATLAB, right? I think you can see it. No, yeah, you can see it now. And first, explain what is MATLAB, right? Well, MATLAB is more than just programming language. MATLAB it's this also the environment. I would like to say that it's like an environment. It stands for Matrix Laboratory, just like that, Matrix Laboratory. For what I know about this amazing technology is that it was developed due to the necessity of handling data. It's a language that is not zero index based. That means we start counting not like in other uh, languages like JavaScript, Python, etc. In zero. We start counting in one, so it's more like natural if you think of that way. So many people tend to count this, and well, for the people that develop MATLAB, it makes sense to do it in a more natural way. So it's one based index. So we start counting from one. What else we have to say? MATLAB comes with many other things. For example, if I have to compare it with Python, I will say Python it's really great. And once you manage it, and once you learn how to configure your working environments, your virtual environments, um, download the proper tools. For example, if you want to do like scientific stuff, SciPy, NumPy, Matplotlib, or the library you want to display the data on, and etc. It's really good. Um, but it's hard to learn, like there's a big curve here. And in MATLAB, that comes really easy. In MATLAB, all it's already packed up and ready for you to use, ready for you to just focus on the analysis, not the configuration, not all that hard work. The disadvantage is that it is not free. If you see here on the header of my computer, it says MATLAB academic use. And that's because this license was provided to me thanks to my university. Probably many of you have this at yours. For example, I see here the comment for circuit student at my school. All the engineering students have to use it at least a little. And yes, that's really true. And the good news is that if you're a student, but your university doesn't provide to you a Matlab license, you can come to the MLH page, and we have a Matlab license for 3 months for you to use. So thanks, Matlab, for providing us this amazing tool for the people to get to know it. Because once you get to know it, it's really good. I swear. At first, I have to admit, I was kind of how to say, not in my best mood for using Matlab because it's a paid software, and me being more young, being more I don't know how to say it, anarchic, maybe. I was like, why am I going to pay for use that? Then you start understanding more life, and and you realize that there has to be a trade-off, right? And plus, if your work provides it for you, it's a great tool, and very common for academic purposes. The thing here also is that we start seeing more MATLAB not just in the academic environments, but in real environments, in production, in working scenarios, for example, for robotics and for data analysis, for machine learning applications, and all those stuff. And the MATLAB team is developing great tools for artificial intelligence, machine learning, deep learning, um, the control system of if you want to do heavy engineering stuff, MATLAB packages are really good for that. For example, I was taking a class on advanced control. Here's an example. I can show it to you. Um, Here we define our system in space state representation, and I give the matrices for the system, and the output it's all the matrix A, B, C, and D for the characteristic function. Then we give desired how to say it, what's the name of this in English? Impedance, like the impedance value. And just with a simple function, we calculate the controllability matrix, which is this, and we get the keys for the function place. And well, this is a heavy analysis, I have to say. In paper, when you do it, just calculus and calculus, you get like 40 pages of this. And in MATLAB, the code is not that complex because all of the functions that already comes with it. And again, you get what you decide. You get um, graphics to display it. You get the values, the calculus, etc. And it's really great. Uh, Mine's still college. It's private. If I provide them good results in my parts, they can even marry or present out to me. So this MATLAB is not much of a problem. Uh, okay. Um, don't understand that, but okay. Um, Returning to the point of MATLAB. I think you. No, yeah. Sorry, for a moment I thought I wasn't sharing my screen, but yeah, you can see it, right? Just help me confirm here on the comments if you can see it. But yeah, returning to the point. If I want to do this in Python, it will be really more complex. And yeah, thank you, Green Yoshis. And I know that because I tried. I well again I was mentioning that in my university we use Matlab not as an optional tool because they provide it to us, but as between quotes forced tool because all the teachers are capacitated, are instructed, sorry, to use MATLAB. So that's the way they teach using MATLAB. So it's necessary for you to learn it and to handle your assignments in MATLAB too. And that's one of the reasons I was angry with MATLAB at first. Then I started studying Python on my own, and for this course specifically, I thought, hey, I could do this in Python. So I tried, I did it. Yeah, I did it. I achieved it. I do the same in MATLAB and in Python, and I compared. For example, for this specifically, that it's robust control, you need a tool that comes in Python that has a specific part dedicated to say, if you did this with MATLAB, this will be the translation. Or if you want to do it the way you do it in MATLAB, this will be the translation. Because they know MATLAB is so good for this. They know MATLAB it's too good at engineering, for robotics, for control, for processing mathematics formulas, etc. That's the great reason of learning MATLAB. Um, yes, we can see. Thank you so much. So I hope this gets you interested in learning the tool. Now you know what MATLAB is. You know why MATLAB is great. So let's start from the beginning. Right? I'm going to open this. And first of the editor, I want you to get used to the interface. So in our left section, we have like the folder tree. If, for example, if you are used to Visual Studio Code, this will be the same. Here is where are your steps. For example, I am in my users folder, my name, MATLAB Drive, because I use the MATLAB online storage. Helps me handle my files through many devices. And I create a folder with the name of my university, and then one with the class I was taking. Um, so the current folder, no much to say. That's intuitive, right? Then we have at the command window, and you can think at the command window as well, as that, as a command window. You can type here comments. It's your terminal. You can do many things like clear. You can create here variables of MATLAB. For example, a equals 10, and you get a. And I want you to take notice of something else. On our right side, we have something called the workspace. And in our workspace, when now I created here on the command window a variable called a equal to 10, we have the name of this variable and the value here. So we can display this. And now, for example, I can say, hey, and it's going to tell me a equals 10 because it's a variable name. All variables names and its value can be displayed here on the workspace. This is very useful. I like this because you can take, for example, let me just move from folder to MATLAB Drive. I will create a new folder called MLH. And this MLH folder will contain another new folder called Global Hackweek. And here I'm going to open a new script. Don't put too much attention here. I will explain what this means. And Sorry, I didn't explain this. Here we are now on the editor. Now we see the current folder or the folder tree, the command window, the workspace, and the editor. Normally, I try to work more with the editor than with the command window. The command window comes really useful when you just want to make quick comments, right? For example, when you have a function in here, declare, and you just want to execute that function. Um, and I have to say, that now that I am explaining this and I'm thinking of the reason of having this common window and the editor and etc., it really depends on your workflow, right? But I'm going to tell you about mine. I try not to use many scripts. I try to use more live scripts, and I'm going to explain that in a second. But as you can see, we have script, live script, functions, live functions, and class, test class. I have to be honest, I never use this. But scripts, live scripts, and functions. Those are the ones I use. Script. You can think this script as a .n file containing your code. So let's start creating some variables. A equal 10, B equal 20, and C equal A plus B. Right? Really, really easy. And a semicolon after. Okay. This marks as a warning, but actually, I wanted to do this in purpose. When you declare a variable in Matlab, you do it as in many other programming languages. You just type the name of the variable, um, the equal statement, and the variable value. We can comment this. In MATLAB, we comment using this percentage symbol. And that will be it. This is an A, the variable name, equal the value 10. Same for this. And we can perform operations doing this. We can say C equal A plus B. We can say D equal A times with an asterisk B. We can say A, B, C, D, E equal A. We are going to divide by B. Or we can even say F equal A. What else? Well, minus, and all that's case, right? So this is not that complicated. I want to take advantage of this to show another thing. That is, we can execute this here on the run section. I'm going to call this because an M file asks you for things to be saved. Now we can say see this is a test.m, which is the MATLAB extension for scripts. And we see now here in Workspace that we have been created F, E, D, C, V, and all these variables, right? And we can see their values. Now, see the difference and see why this is showing this warning. If I create A equals 10 here, or equals 50 here, we can see even the previous value of A was 10. Now I declare here on the command window, and here now A value is 50. So all these it's related. And which path the common window takes? Well, the one in our current folder. So if I add a semicolon, plus we have the result here. Not only we declare it, but now the result shows a equals 50. If I do the same, a equals 100, but this time I add a semicolon, we don't receive an output. The semicolon in Matlab says, don't give me the output. Don't display the output. I don't want to know it. And you'll probably be wondering why anyone will do that. Well, uh, there are times when actually you are sure and you're reading this code, don't need to execute it, are for sure which probably has values. For example, here, yeah, I don't want to show all these values here. I just want to perform the operations that I can use another statement that is display C, for example. Well, A. And which one programmatic use of display it's not recommended. Print F, for example. Well, this changes. This, sorry. And I run this. You see on the command window, I got a result. So this is like the script, the file script, and here I have the result at the command window, right? Because I say, hey, this, hey, the test file told us the result or the output is 10. But in this point in life, for example, if I remove the A and I run again this, this still works because, well, before I say it, because why do you think that's still working? In any other programming language, if I remove a variable but I perform operations with that variable in the same script, you're probably wondering why this doesn't break if A doesn't exist anymore on the script. And I'm not lying. I can run this again and again and again, and you can see I can clear the command window and run it, and again, it's 10. Why? Tell me why. You may probably know the answer because many of you have used Matlab before, but I want to see if you're putting attention. Hello, Alberto. How are you? Hey, for nice to see you here. It's like Python having a script in one window and a terminal in another. Yeah, this workflow is very similar to that. So you can use terminal to check if your syntax does what you think. Then you build your script with pieces of your confident will work. Yeah, yeah, it's like that. And as I was saying, it depends on your workflow with MATLAB. Mine, it's not this. I have to admit. But there is another similitude with Python in my workflow. We will get to that. First, answer to this. Why this works if A doesn't exist anymore on script? Well, the answer is because it still exists on the workspace. We are not assigning the value anymore here when run script, but I can even delete all of this or even comment it to make it simpler. And if I run this, value will be the same. The workspace variables will have the same value. It doesn't matter if I'm not declaring them or performing the operations every time I run the script because MATLAB keeps storage of your variables values. MATLAB keeps that in the run environment. So to delete a variable, we can do another thing that is clear. Clear A. Now I clear A. It's not showing here on the workspace. And now if I want to run this, and I display, and I run this and the disk, it tells me there's a mistake. I don't recognize a function or a variable that it's called a. I don't know what you're talking about, bro. And that's because we deleted, we cleared a. Now it's not on workspace. Now, if we do uncomment this and want to run this again, it will throw us an error because we have B. But for C, if you want to do a non-recognized function that it's called A plus B, that I know what it is, but A doesn't exist anymore. And we can do another thing. On common window, we can add A, for example, here, and say again, this is 10. It is not on the how to say, on the script, but it is on our workspace. And now we can run this again, and here it is. Here is 10 again. Now C knows what to do when A plus B comes, because now we know what A is and now we know what B is. It doesn't matter if A was declared on the command window and B is declared every time we run the script, because both are declared and recognized for the runtime here on the workspace. So that's not a very similar thing to Python, right? Python doesn't do that because the variables are saving the values in the workspace exactly as is in memory. Exactly. Yeah, yeah. That's the reason. So many people tend to do this thing, that is CLC to clear the command window, clear all to close all variables on workspace, and close all for closing the figures that are created when you run. For example, if let me how to say, well, when you plot things here on Matlab, the Matlab environment doesn't plot it here on the command window because it will look terrible. It opens a new window that it's called the figure, and you probably be opening many of these figures, and to avoid closing them with the X button or on the right if you're on Windows, the one thing you can do is the statement close all, and that helps you with that. What else? And yeah, now if I perform this will give me an error because there is no more A, and I have to declare it here and run this, and now there is no problem, right? Every time the script is run, the command window is reset, the clear the workspace is reserved, and all the figures are closed. Um, and yeah, that's a workflow. But let me show you another one. And this will be very familiar to you if you know what notebooks are. Colab, Jupyter Notebooks, etc. Live scripts. We have the .m file for Matlab, and live scripts are .mlx or live scripts. In this case, we can perform operations per blocks. And to be honest, when I do this, I tend to not use command window because I don't find it necessary. Now we can do the same here. A times A equals 50. Uh, B equals 20. Um, that's a shortcut to change blocks. You can come here and hit insert section, insert block, blah blah blah. Or you can do double percentage and enter. And see, for example, we'll say again it's A plus B, and in this case, the it's A times B. And let's run all, not the section, but let's run all. Let's first clear the workspace. And this is another very interesting thing. For example, let's return to the test. And we are not using here anymore the variable declarations. We are going to comment this, and we are going to comment also this. For example, I come here, I run this, and now in my workspace, I have declared A, B, C, and D. If I come here, even that is another file, but we are working on the same folder, I can run this too, and it will give me no error because A and B, even that they are not participating here on this file, are declared on the workspace. That's uh, part of the memory thing, blah blah blah. But well, it's a very interesting thing because you can do certain things like this. You can come here and you can keep save, yeah, for the workspace for your values. So you save your values, and that's an extension called .mat. So let's say test values, and you save them, and here they are. So we can come, we can clear the workspace. All variables will be deleted, okay, and you can double click here, and there are again restored all your values. So let's delete them again. CLC clear all from a file. It doesn't matter if it's .m or .mxl. Um, just a quick clarification here. These are not different types. These are not different languages. These are not different MATLABs. It's the same MATLAB. It's the same language. It's the same in every aspect except on how they behave. Here, you run all the script like in a Python file. And here's the other comparison. And here, and you have the output on your command window, like in Python, the terminal, right? And in the live script, it's like a notebook because you run the specific blocks. And for example, here's when it comes handy, the semicolon thing, because I can run this and the output will be displayed here. Actually, you can change it. If you see here, I added, there are new options that we can see the result on the right side on the bottom, or just the results at all. Not the code, just the results, right? So this is like a notebook. So I have no output on the command. The output is now shown here. But yeah, it's still the same code and everything. And if I do again CLC clear all and close all, and I run this section, you will see there's no values at all in the workspace because, and in this part I run only this section. I didn't run this all. If I run the entire file, now they are clear before, but at this point they are already clear again. And we can open the test values.mat. So in this case, we are going to declare the values here. Run it. Well, declare the values here. Run cls clear all. Run this. Save this. Test values 2. Come this other way. Open test values 2.mat, and we will see that running all these unrecognized function. Oh, and struct with fit. Oh, so we need to, yeah, hey, we need to do another thing that it's here. Hey, come up. Hop on too many. Oh, well, what's this? X. Let's run only this section. A struct with fields. How do I destruct this? I don't remember. Well, let me see if you have any questions this far. What are we expected to do in this hackathon? Any challenge or roadmaps? Actually, this is not a hackathon per se. This is a global hack week in which we have, yes, challenges for us to win community points. But this session is just informative for you to learn Matlab. Same as this, we have the whole week full of sessions. For example, besides this, I will be giving JavaScript introduction workshop. It will be a series of four technical sessions in which we are going to explore the language in depth, the basic things as variables, operations, structures, etc., to how it works inside the event loop, the queues, the stacks, and everything. Yeah, so same as me, many other coaches and great streamers will be giving these sessions. You can use a for loop to iterate over each row of the file when opening the file. Yeah, probably. I remember it was an easier way, but I don't remember how, to be honest. It doesn't harm to Google it very quickly. Um, Import mat files into Matlab. Yeah, yeah. It's supposed to be the way. Oh no, I think I'm using the wrong operation here. Yeah, I believe it's not open, it's load. What? My cursor is gone. Let me stop sharing my screen because I think something broke here. I don't have my cursor, and I'm not liking this. Yeah, I'm just I'll be stop sharing and open it again because yeah, now my cursor is back. We can see, yeah, you can see it, but I couldn't. Sorry. Okay, I think your data is now at x.a maybe. Uh, no, yeah, it was simpler than that. Sorry, I was using the no again. I think it's MATLAB, the one that's not working fine. I'm going to save this file, save as test2, close it and open it again. Yeah, works fine now. Okay, perfect. Yeah, sorry, I was hitting open and it's loaded. That's why. So let's delete the section. No variables here on workspace. Then we load them to our workspace. I'll be hitting the shortcut that it's command enter to perform these sections. You can see this is the one I run. If I run the entire file, you will see here the difference. Well, you see the difference here on workspace. I have now D and B, but I will delete them again. I load section. Now I have A and B. And if I want to do C, now variables are recognized because I loaded on the workspace. And I can do this and I can do this other thing, right? So this point, now we are familiar. And I would like to do this recap so everybody understand what's happening. Now we are familiar with what MATLAB is, why MATLAB is great, how different workflows are happening here on MATLAB. We see the script and the lab scripts. Now we are familiar also with the workspace, the common window, the whole environment for using MATLAB, which again, it's very important because it's similar to Python, but not that similar and has more advantage in it and advantages. Uh, well, I won't say it's better, but for sure it's different. So that's it. And what else? We have seen how to perform operations, how to declare variables, and let's get more in deep on the why this is called matrix laboratory. Types of data. You'll see here the value, right? Open selection. If I open this variable, you will see this is a double, right? But let's return to this live editor. Um, yeah. Okay, let's do another A, B, C, D, E, and let's add many variables to this. I forgot the equal. So this will be lots of values, right? We run this and we open this, and we um, let's open this one too. It's still a double, right? But let's do another one. A B C D E F. This will be 1.0. We run this and we run 1.0. Even though I added the dot zero, I want you to check that here on the values, this is just displayed at 1, right? Let's open the selection. Double again. So what does that mean? It doesn't care too much here on MATLAB what these types means because they only manage the amount of memory that you are given. For example, in in Python, it's the same. You can use e equals 2 or e equals 2.0, and Python will say, okay, it doesn't matter if one is an integer and the other probably can be a floating number. I just want to use a double for both. Double spaced memory that it's I don't remember how many bytes, but that's too technical. The thing here is that MATLAB, that it's matrix laboratory again, all of the values will be matrices. And let's create then our first matrix. This will be just for purpose of this session. Don't take it as a rule. A or majus numbers, the uppercase value for matrices. And one way we can declare a matrix is here with the square brackets. I will remove the semicolon for all of this so you can see the outputs. And for example, we have metric. Let's understand what a matrix is. Let's go that step before, right? A matrix is a set of values of many dimensions. What does that mean? It means that, for example, a number, a single number, it's a matrix of one dimension. We have rows and we have columns. If we have a row of one and a column of one, it means we only have a value of one, right? So let's do it. Let's run all of this, and you will see difference between these even more. Let's add another that will be f ABC g dot zero, one with the dot zero, right? All of the displays are one because again I told you that here all the values are matrices. So this is a matrix. It doesn't matter, it doesn't have the square brackets. This is another matrix. It doesn't matter, it doesn't have the square matrix. This is a matrix. It has the square brackets. And since it's just a matrix of 1 times 1, here even says here the use of the square brackets it's unnecessary. We understand for us in Matlab this is a matrix. You don't need to tell us this is a matrix. Even more, this is just a 1 times 1. But what happens if I add more? Let's say b. So this will be a matrix of 1 times 1 times 2. This double point is how we again well let's create this matrix. So let's run it. This is a matrix and the size it's given here because now we can open this here, open selection, and again it's a 1 times 2 matrix. 1 1 times 1 1 times 1 double. So types of values here in Matlab you probably will see here double or whatever. This one doesn't care too much. The one that cares is this other one for matrices. Even more, the variable specific view for the variables. Sorry, the window specific view for the variables. It's almost like an Excel, right? Because here you can see how it's done. So first value of the first column, it's 1. First value of the second column, it's 1. That means this is a 1 times 2 matrix. Matrices of one value in even column or row, however you can think of it, are called vectors. Or you probably heard of this as arrays in Python, right? Now everything's getting more familiar, right? So we can say C, for example. Let's create another vector or matrix with different values. So this will be a 10 times 1 matrix. Well, a vector, because remember, times 1. When you have one value in even rows or columns, you will have this conjunction. But we can do another thing. We can transpose that with this sign. We can, for example, if I have here a matrix that is 1 times 10 with this value, we can say now I want it 10 times 1. Let's run this. You see? You see how we transpose the vector in this case? And we will be creating column matrices. Let's create a row matrix or a transpose vector, but for its beginning, A, B, C, D. How we do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And run this section. You will see if I separate values with a space, this means different column. If I separate values with a semicolon inside the square brackets, this means different row, right? Let me see if you have any question this far. At least Pachuca Pachanga. At the last Pachuca Pachanga, I ran so hard my lungs clapped and my nachos got noisy. Wow, you have fun. Okay. I think you didn't do that actually. I think you're just making fun statements at word mix of Spanish, but yeah, it's funny. So no questions this far about Matlab, right? Let's return to this session. Um, but let's create then symmetric matrices. A symmetric matrix means same values, same size columns that are rows, right? So let's create, well, in this case, and if I transpose this column matrix, will receive a vector matrix like this one. See? So like the opposite. But here was declared the column matrix from its creation, then transpose it, and here it was created vector matrix, and then transpose it to be a column one. What else? A, B, C, D, E. Let's create again the symmetric one. So this will be 0, 0, space separate, then semicolon, then 0, then 0. And let's run this. So this is a 2 times 2. Let's make it bigger. Let's make it a 3 times 3. Oh, sorry. I need to add another step here to make it 3 times 3, obviously. And make it bigger. Let's make it 4 times 4. Then I need to add another. So you see, if we open this, let's see again to the variables. We have 0 at position 1, 1, 0 at position 1, 2, 0 at position 3, 4. But let's explore. Let's then change the zeros. Let's do 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And let's run this and then open this. You see here, even so the value is too long that it doesn't show the value anymore. It shows the type of the value. Let's open the selection. So in position 1, 1, we have 0. In position 2, 1, we have 1, 2, then 2, then 3, then 4, and more and more and more and more, right? So that this is a symmetric matrix because we have 4 columns and 4 rows. These ones comes very handy, and these ones are probably the ones we want to work with more. But as you may be thinking, this starts getting more and more complex. And writing these can be, well, in this case, tedious, right? But there are many functions that help us with that. For example, zeros. And you say just the size of this. I want a size of 3. And let's run this. So we have a matrix 3 times 3 of zeros. Let's make it 4. Well, bigger, right? But let's make it 40. Well, more bigger. And imagine trying to type all of these in 40. I will have to do something like this and this and this and very noisy, right? So this function really comes handy for that. And let's make it again for one. And we have ones, for example. And another thing that we are making it a symmetric matrix, right? But we can change it. We can do a two um, size. I don't remember if it's a comma. But let's try it. Yeah, it's a comma. Um, two uh, two rows, 6 columns. But let's make it the other time. 6 rows, 2 columns, right? So these are not symmetric, but you can specify the size of your matrix. Well, the one that you want. Um, what else? Oh, this one. This is very this is a very useful tool that it's linspace. Linspace, as here the shortcut says. Well, um, linspace generate linearly separates vectors. Remember, a vector it's a matrix of one value in its row or in its column. Linspace. And what linspace wants, it's what you want to start. I will want to start in 1. And then when you want to end, I will end in 10. And how many values do you want in that separation? Let's give it a 10. So what do we have? A vector very similar to what we created here, that it's 1, 2, 3, 4, 5. But let's say we want to start in 1 and end in 100. Well, that can be annoying to type, right? But here with linspace, it's very simple. And we have it. We have 1, 2, 3, 4, 5, 6, 7, 8, 10 until 100. But let's say that you want to start in 1 and you want to end in 10, but you only want 10 values. So this is a 1 times 10 vector separated, evenly separated in 10 values. So we have 1, 12, 23, 34, 45, 65, 67, 89, and 100. Another way to do this is with these separators, double points, right? So this is evenly separated values. You want to start from here, you want to end here, and how many values you want. Now, for example, I want to start in 1, I want to end in 10 and 100, sorry, but I want not evenly separated values, but I want, sorry, no, I don't want a specific number of values, in this case 10. I want them to be separated by 10. So let's run this. We will receive 1, 11, 21, 31, 41, 51, 61, 71, 81. But here's the trick. Well, here's when it's tricky. Because in lane space, you specify you want to end in 100 and you want 10 values. So Matlab performs the calculus to do that. You just want to start in 1 and end in 10. What is in the middle, it's problem for Matlab. In this case, in this syntax, the problem is for you, because if you say I want to start in 1 and I want to end in 10, but I want separation of 10 values per number, well, you have to do the calculus yourself, because as you see here, this doesn't work. I am not going in 100, because the next value here will be 101. That doesn't complete or requirement. We say here, for example, if I add the other one, we will have that. We will have the value of 1 and starting in 1 and then in 101. So here, what it's important, it's how do you want to separate your values in the middle? Here, what is important are your limits. What is in the middle, you don't care for it. Or, well, you care, but it's up to Matlab to decide which values to put here. In this case, for example, if you want to separate values from 0 to 10 and 100, then again, the problem is that you don't have a 10 matrix, 10 size matrix in columns, you have 11. But in this case, you have 0, 10, 20, 30, 50, 60, 70, blah, 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 until 100. And that's how this works. What else? What else for a Matlab 101? Some forms to create. Oh, well, same as we did the operations with these matrices, because remember, these are matrices. A is a 1 times 1 matrix. B it's a 1 times 1 matrix. We can perform operations for meter matrices. There are certain rules for performing operations in matrices. This probably you will remember your calculus classes, but Matlab comes really helpful for that. So let's imagine we have again an A. It doesn't matter the name of the variables anymore. An A matrix that it's 1, 1, 1. And a B matrix that is 5, 5. So we have a 1 times 2 matrix, vector, and a 2 times 1. Remember, I'm going to do this in a different. Let me change this a second. A, B, C, and D. This will be 3 and 3, and this will be 2 and 2. So these are our matrices, right? Let's do some operations with this. If we want to sum, for example, A plus B, the output would be 1, 1, 5, 5. So what happened? What happened here? Let's do a little bit a simpler thing. Let's just sum A plus 1 value plus 3. What happened? To each value here, to each value of the matrix, we sum 3. If we sum two different matrices, we take the row, the first, and add it to the column, to the first column of the other. We take the second row of the first one and we add it to the second row of the other. If we want to do this, for example, with two matrices that are not symmetric, column times rows, this will throw us an error. Well, in this case, it didn't. Um, okay, I don't know all the rules, but what I do remember, for example, for addition, for not for addition, sorry, for multiplication, it's that this will throw us an error. And here, incorrect dimensions for the matrix, because we need to multiply only matrices that has the same value of here, for example, the columns to the rows. So 2 and 2 are equal. That's why this can be done, A times B. But A has 1 times 2, and C it's 1 times 2, 2. So 2 and 1 are not equal. So they're not uh, match for setting it in a way. And Matlab explains that to you. Incorrect dimensions of the multiplication. That's check that the number of columns in the first matrix matches the number of rows in the second matrix. To operate each element of the matrix individually, use dot terms. And this is very useful. So this is not allowed, right? But we can do dot times. And what happens? We have 3, 3. This is not an error, but it is not what you be thinking of doing. And probably this is what happened when we want to do the addition. Uh, oh, sorry, I have to sneeze. Yeah, this is not an error indeed, right? But this is not a correct operation for matrices because this dot what indicates it's perform this operation value by value. And this dot is the exception because again MATLAB it's focused or it's themed for matrices. But at some point, scientists or the people that are using MATLAB realize that they do need to perform operations with not matrices too, but with scalar numbers. The scalar number it's for example the matrix of 1 times 1. Remember that? Remember the first examples? That's a scalar, right? Remember? A matrix with one value in its row or its column, it's a vector. We have matrices, we have vectors, and we have scalar numbers, right? There's a category above that, for example, in this dimension, this is 1 times 1, this is 1 times n, this is n times n. And if you have, imagine putting a matrix inside another matrix, well, that's a tesseract. But that's huge. Don't worry for that at this moment. You're just learning MATLAB. Um, and here, for performing operations with scalar numbers, same as we did here, I'm going to separate this to make it easier. Oh, sorry. Here, I can do this, will be the same. But the the performance here, it's different. Here, since we are only multiplying by a matrix 1 times 1, you will be thinking, hey, Alberto, you just told me that, for example, A, it's a 1 times 2, and 3 it's a 1 times 1 matrix. Why? Here it throws an error and it says the number of columns must match the number of rows of the second, but here it doesn't, because the number of columns here are 2 and the number of rows here is 1. Why this is not an error? Well, internally what Matlab it's doing this. But this is syntactic sugar. You're safe to do this without problem, because once we have a matrix of 1 times 1, Matlab understands that this is a scalar number. So this will be performed by default for you. You don't need to worry about it. Now, if we add this, I'm not sure what will happen. Well, even if you add the square brackets and you indicate this is a matrix, it's the same. MATLAB says, hey, I know it's a matrix, but I know it's a scalar too. So if you want to perform an operation like this, that this dimension of this doesn't match, I will perform this for you. Don't worry. But in this case, this is not that intuitive for MATLAB, because this can be a problem. This can be something you don't wish to do, right? So in this case, to avoid confusions and to avoid problems, MATLAB says, hey, if you want to perform multiplication for matrices, that's not allowed. You cannot do that. But if you want to perform a value by value multiplication of these two matrices, just add the dot, and we can do that. And same for every other operator. Same for the tab, for the plus, for the minus, for the division, for every other numbers, right? So in this case, this can be done, and this is a value by value performance multiplication, addition, division, etc. Right? So that's how MATLAB works. Plots, yeah, thank you. Okay, let's start with some plots. Seems good to me. Before we start with these plots, let me create a T. And this T will be a link space from, no, not a link space. Oh yeah, a link space from 1 to 100, well, to 10, separated with 100 values. 1000 values, sorry. So, very, very small separation, right? You see? Uh, and let's add a next, which is a sin function of t. And we have now this way. But the great way to show it, it's not with numbers. We want to plot it, right? So it's very easy, actually. We just need to plot and say the y, which will be t, and x, and we run this. And here it is. Nothing more, nothing less. Let's do another thing, which is, let's multiply this for 550. Yeah, no. Inside, yeah. Oh, 50 was too much. Maybe 10. Maybe 4. Okay, this looks better. And what happened? Oh, well, let's start from 0, yeah. Yeah, now it looks better. Let's change some things. about this plot. There are some things that I don't like. For example, let's have a legend. This will be sinus. Let's change the color to a red, and let's um, xlim will be 1.5, and minus 1.5. And I don't remember if we do that way. Okay, the xlim doesn't work. Um, Maybe if I store this in a variable, I don't remember if it was done this way. Okay, yeah, I don't remember how it was done, but okay. I just wanted to add more space. um, but yeah, this is how you plot. Let's look at how we add that space. I don't remember, to be honest. Plot x limits Matlab. Yeah, it's with xlim. Yeah, it was with xlim. Sorry, but what I did wrong, it's not equal. It's it's a function. My bad. Oh yeah, and this is wrong because it's yeah. It was the other way. It appears to be the function. No, what happened? Oh yeah, the comma here. Excellent, excellent. Oh, maybe. Yeah, sorry. I was thinking wrong. But yeah, this is how it's done. Let's manipulate this a little bit more. This is too compact. Let's do another thing and let's add a dash to be dashed. You can see the difference? No, I don't. So let's add another dash. Yeah, here. And let's do. I want you to check this. Oh well, this is not necessary to be saved here. If I do another plot of, let's call these x2, this will equal to cosine of t times 3, plot y dot x2, and let's run this. Oh yeah, it is not y, it's t, sorry. Come on. It is in a separate plot, right? But we can do one thing, that is hold on and then hold off, and you will see both are combined here. And since we said that this was red, now we need to make it blue again. Oh, sorry, it was here. Nice, isn't it? But also we need to add a legend for that. Yeah, I remember. Yeah, now it is. We have the sinus and the sinus here on the same graphic represented. We can make one wider than the other. Um, the double, to be more specific. We can manipulate it, we can change the data, we create a line space. That's a lot of information. It was very, very crash course, but I hoped to teach you what you needed to know for the basics of Matlab. I think we are good to end our session now. And if you like it, if you really enjoy it and are more excited to learn more of MATLAB in future, like more advanced things, like doing things like this for robotic control. I don't know for what was this? See to transform, how to, for example, here do mathematical functions. MATLAB has a great, great symbolic library, so we can do this, and you can actually write. An equation and it will be resolved. It has its limits. Don't expect to do all your homework here, but it's really great. But again, this is heavy, and we are not how to say it, prepared yet to go to that. This was more think of as an introduction of fundamentals for MATLAB, and I really like to share these things with you. If you want more of MATLAB, let me know on the comments. Um, how do we get access to MATLAB through MLH? You can Google it. Let's do it. Give me a second. Um, in the events where MATLAB is one of our partners, they share a link, but I'm sure it's something like mlh.io/MATLAB or something like that. Or, I don't know. Um, uh, hack AC/MATLAB, maybe. Oh, some MATLAB hackathons. How to get MATLAB? You will need MATLAB's account on the computer relate. Ah, here. Yeah. For example, asked MATLAB to the workshop, used mail with the mail link hacking, etc. Blah blah blah. Well, here you just type on your URL hack. How I type hack what hack.ac hackb.ac/MATLAB, and that's all. Nice. Is there a recommended free alternative to MATLAB? Yeah, Python. Yeah, I just did that. Python. And again, I mention it. You can do whatever you want with Python, same as in MATLAB. The difference is just how the tool performs, integrated stuff. MATLAB, it's once you learn it, it's really simple, and it just gets simpler, to be honest. Um, and Python, well, has its problems, but it's really really good, right? Octave was the free version a few years ago, and I haven't tried it, but I heard of it. So thanks for the recommendation here. So That's all. Thank you so much for joining me here and for being here with Merely Hacking to this season start. We are really glad to have you. Join me next Monday for my JavaScript Universe session, in which we will explore all JavaScript universe, all of it. I swear. We will have four parts of that. We will start a little bit slow with the basics, but then it gets really complicated, but also really excited. And I hope you have the words to explain the complex for JavaScript. I really love the language. You know that, and yeah, JavaScript is the best. And again, let me know. Let me know if you want more Matlab. I know the bad thing it's not free, but it has their good and great advantage. And I can do another session about, for example, comparing Matlab with Python and how you can do some things in order and what changes. Um, but Matlab and Python, I want to say this, are not enemies. They are not fight. The opposite. They are very well complemented. They actually released something that calls the MATLAB engine for Python, and you can create MATLAB functions and then execute them in Python, and it's really great because you have the benefits and the great advantages of both worlds. And well, I just want to excite you to allow me to get more sessions like this. MATLAB with Simulink. Simulink is another great thing. Can perform exciting tasks. Yeah, I must learn this. Yeah, exactly. So again, see you. Thank you so much, and well, I'll be back for this global hack week. Stay tuned. What comes next? And happy hacking, hackers!